In this video, I'd like to talk about the math question of the day for January 26, 2023. And we need to find two positive numbers whose sum is 300 and whose product is a maximum. Now, this word here, maximum, that is a clue that this is an optimization problem. Or in other words, this problem comes from Calculus 1, where whenever we need to find the maximum or the minimum, we will need to use the techniques of calculus and finding derivatives. So at this point, go ahead and pause the video, see if you can work this out on your own. You could guess and check, but it's difficult to know if your answer actually produces a maximum without looking at all possible values, and calculus will save you quite a bit of time there. So pause the video, see if you can work this out on your own, and when you're ready, we will go through this together. Now, assuming that you've given this problem a shot, we can go through this together. And to start, we can define our two positive numbers as just x and y. And we know their sum is 300, so we can say that x plus y is 300. And we also need to consider their product, x multiplied by y. And we're told this is a maximum. So let's look at this as a function. Let's just say this is equal to p for product. And we have two equations with two variables. Actually, we do have a third variable, but we will use calculus on this equation here. So to start, let's solve for either x or y and substitute it into this equation so that we can transform this into a function of one variable. So let's solve this for y. We can say that y is just 300 minus x and then replace it there so that we get x multiplied by 300 minus x. This is equal to the product. And distributing, we get 300x minus x squared is equal to this product here. Now, whenever finding a maximum or a minimum value in a function, we need to look at the function's derivative. Namely, we need to look at when that derivative is equal to 0. So if we have some graph of some random function, let's say it looks like that, when we look at the derivative of a function, remember that we're looking at how the function is changing, its rate of change. Or in other words, if we, let's say, took the derivative at this point, it will give us a number that will tell us the slope of the line that is tangent to the function at that point. So if we, let's say, looked at this point, its value of the derivative would tell us the slope of this line that is tangent to the function at that point. It just touches at that point. That's what tangent means. So when we consider the maximum or the minimum points, this point right here and this point right here, notice that the tangent line would be a horizontal line. And since these lines are horizontal, we know that the slope of these lines are just equal to 0. Or in other words, we can say that the derivative of our function here is equal to 0. We call these critical points. So to find the critical points here so that we can identify the maximum or the minimum or both, we will need to take this function's derivative. And to do that, we can just use the power rule here. We bring down the exponent, we multiply, and then we subtract that exponent by 1. We do the same here. We bring down the exponent, we then multiply by this term here where the exponent is reduced by 1. So this will be times by x to the first. And we took a derivative with respect to x, so this just becomes the derivative of that product with respect to x. Now we can rewrite this a little bit simpler, that x to the 0, that's just 1, so we get 300 minus 2x is equal to the derivative of that product with respect to x. And again, we're looking at the critical points when this derivative, when this slope is equal to 0. Now, if we solve this equation, we can add 2x to each side. So we get 300 is 2x. We can find that x is 150. And this also would make y 150. But remember that these critical points are for both maximums and minimums. So the question becomes, how do we know that we didn't just find a minimum value? We don't want to just assume that this value of x and also that same value for y will actually produce a maximum. And the way to determine that is to look at the second derivative. This is often a step that students overlook, but we do need to prove that it's this case and not this case. Now, looking at the second derivative, that tells us how the slope, or the first derivative, is changing. So if we look at the slope as it approaches a maximum, notice that the slope of this tangent line is decreasing. And as we go through this maximum, that slope is getting more and more negative, or approaching negative numbers. And for a maximum point, we would say that the second derivative, which we'll use two dashes for, this is the first derivative, this is our function x, then the second derivative at a maximum is a negative number. The slope is decreasing. Whereas when we're dealing with a minimum point, notice that the slope is getting bigger and bigger. It starts negative, then goes to 0, and then gets bigger and bigger. So here we would say that the second derivative is positive. So if we take the second derivative and it's always negative, then we know for sure this is a maximum point and we can feel confident about our answer. So to take the second derivative, we will just apply that power rule again. So let me just make a little bit of room here. And we want the second derivative of our product with respect to x. The derivative of a constant is 0, and this is to the first power, so we bring down the 1, we get minus 2 multiplied by x to the 0, which is 0. And since our second derivative is always negative, that tells us that this x value of 150 and the y value of 150, this will in fact produce a maximum value.